All right, students, let's start with today's topic, a very new topic, that is electrochemistry. See, what we have been studied in our chemistry, I have already told you. There are three different branches of chemistry: the physical, the inorganic, and the organic. The topic we have been discussing till now, all are based on the topic, the physical chemistry. है ना? And the physical chemistry basically contains five chapters that are solid state, solution, electrochemistry, chemical kinetics, and the surface chemistry. Okay, all are very simple topic. You have just covered the solution as well as the solid state. And the solid state, I have also seen that everyone has given very good answers, very satisfactory answers. So the next topic is electrochemistry, which is a very brand new topic. And as the name suggests, it is based on electrical changes. The electrochemistry is a branch of chemistry which deals with electrical changes. Basically, it is made up of two words, electrical and the chemistry. So I can say it is the branch of chemistry which deals with the change in electrical energy from chemical change that taking place in redox reaction. Now class, I know very well that you have learned the topic redox reaction. We have studied the topic in your previous class, class 11, and this was very quite interesting and easy topic. What was happening in redox reaction? Redox, as the name suggests, was a reaction in which reduction as well as oxidation both were taking place at once, simultaneously. Okay, so I am saying that there are redox reactions in which reduction and oxidation dono are taking place. But the point is, whenever we apply some electricity over there, there would be some chemical change, or the vice versa. That means if we apply electrical energy, the chemical change is taking place, or we can say the chemical change is converted into electrical energy. I am taking a reaction and I am going to change the chemical reaction over them. I'm putting some reactant, I'm getting some product. But with the help of that chemical change, what we are getting electrical energy. And that electrical energy we are further using in our new topic, or in our new cell, in our new battery. Okay, so this was the whole topic which we are going to discuss about electrical chemistry. Okay, so electrochemistry is very interesting topic, very daily life topic. Basically, if I'm talking about the advantages, the first one is we can get all the idea about the chemical as well as electrical change in redox reaction. Second, we are going to discuss about cell, batteries, and you know what are the advantages of cell and batteries in your daily life. Everyone is using the cell and batteries in their daily life nowadays because it's so common. And now, same as it is if I'm talking about some biological terms, like I'm saying that in our brain, the signal has been taking place. Like I'm speaking to you and you're listening to me. This is all is going on by electrical as well as chemical change. Like I'm saying to you, your brain is sending the signal to your ears that yes, ma'am is speaking something that you have to hear. So these all things have been related to electrochemistry. These are the advantages as well as the topics in which we need to discover electrochemistry. Ban rahi hai baat? Now the point is, I have told you about electrochemistry, that this is the basic definition. What are the actual topics that we're going to discuss in this electrochemistry? Like it is a very vast topic, very big topic. But in short, I can differentiate electrochemistry in three particular topics. That is electrolysis, conductance, and last one is cells, or we can say batteries also. So these are the three topics: electrolysis, conductance, and the cells or batteries. These three topics are the main topics based on electrochemistry, and we are going to differentiate them into subtopics. Okay, so let's begin with our first topic, what electrolysis wants to tell us. What is electrolysis? If I want to give a brief discussion, you know very well, electrolysis means we can say movement of electrons. That means there are some electrolytes. What are electrolytes? Electrolytes are something like acid, base, and salt. And whenever I'm going to give them electrical energy, their electrons have been separating out and they're going to move from one place to another place. That is known as electrolysis. Same as it is about the conductance, I have told you in the solid state we have studied that conductance is due to movement of ions or electrons. This is known as conductance. This topic is somewhat related to physics also. In physics, we have studied what is conductance, what is resistance. I think in 11th class you have studied what is conductance, what is resistance, what is specific conductivity, the Ohm inverse, the Simon, all these terms. So these are the terms we are going to study in conductance. I'm not sure this was topic in 11th class or it is in 12th class physics. So this is a very common topic we will study. In this, all are just the definitions and a simple formulas on the basis of which we will discuss some numerical things. Okay, so this is totally numerical concept. Last one is cells and wet rays. That is totally reaction dependent topic. So now I want to say that we are going to discuss how a cell can be formed and how with the help of combination of cells a new battery can be formed. Okay, so this was the topic which is very important and I can say the main strength of electrochemistry, because a large number of questions have been come from this topic, cells and batteries. Okay, so let's start with our first topic, electrolysis. Today we will just discuss about electrolysis, and on the basis of which a scientist named Faraday. You have heard the name of Faraday very well. In physics also, Faraday was a scientist who gave some laws on the electricity and electrolysis. We will try to cover them topics, but now let's begin with the topic, what is electrochemistry? Okay, so let's start. Sorry, what is electrolysis? I have given the idea about electrolysis also. So let's start with electrolysis. What is an electrolysis? Electrolysis is defined as movement or passage of electrolytes by the presence of electricity. Let's define electrolysis. Electrolysis is defined as the passage or the movement of electrolytes, and electrolytes can be anything, ions, acid, base, electrons, anything. That means they are getting separated, they are getting dissociated. So passage of electrolytes to the electrode due to electrical energy. That means हम उन्हें electrical energy provide करा रहे हैं, and those have been separated out, those have been decomposed, and the movement of these electrons have been taken place. Let's understand this topic with the help of a diagram. Suppose we have been put with two different electrodes. Now, what are the electrodes, bache? Have you heard the name electrodes? You have heard definitely that there are two types of electrode known as anode and cathode. Both are of metal conductors, both are metals, but the point is we have been joined them with different type of we have been joined them with different type of cell that is positive, the bigger sign is representing positive and the lower sign is representing negative. You have heard this, you have learned this signal in the 7th class also. Okay, so I am saying that we have two type of electrodes and this is filled with a solution. Now what's happening? This is my anode, which is connected with positive charge, and this is cathode, which is connected with negative charge. Okay, so now what's happening? Whenever I am going to deliver the electrical energy to this, I'm just providing the electrical energy. Charge, the cathode and anode have been start decomposing, and the cations and anions, that is the two different of ions, they start moving to different sides. What's happening actually? The anions, that is the negatively charged, are moving to anode. The anions, that is the negative charge, are moving to the anode, whereas the cations, that is the positively charged, they are moving to cathode. Okay, so I'm saying cations are moving to cathode, whereas anions are just going to anode. Okay, so this is the whole concept of electrolysis. Now what's happening? Whenever the dissociation has been taking place, the anions and the cations, they have been starting to move into each other side. What's happening? There has been taking place the two type of changes known as primary change as well as the chemical change. Okay, so what is the primary change and the secondary change? Primary change means decomposition has been taking place and the anions and cations are starting to move. And the same as it is, the secondary change is defined that we get the final product by oxidation and reduction process. Okay, so I am going to combine my next topic with oxidation and reduction. I'm going to rub this. I hope you have understood the topic. Now, what I was saying, that we have understood about the anions and the cations. Now we are going to mix them with the oxidation and the reduction. And I have learned this topic by the term lone. Lone means left, oxidation, anode, negative. So it want to say that in the left hand side there is an anode. यही हमने स्टडी किया था ना कि लेफ्ट हैंड साइड में एनोड था जहां पे नेगेटिव चार्ज आयंस हैव बीन गोइंग टू मूव. ओके, सो लेफ्ट anode negative, and we have to learn the topic that at anode oxidation is taking place, whereas at the right hand side reduction is taking place. Okay, so reduction is taking place at cathode. So you can just learn the you can just remember the term lone, left oxidation, anode negative. Let me give you a simple example and you will study how this topic can be used. Okay, let's start with a simple reaction in which both oxidation as well as reduction is being taking place. Let we have lead bromide. Lead bromide, that is PbBr2. So I'm saying that at lead, what is going on over here? The electron has been taken up, that is reduction is taking place. And we have understood that reduction is taking place at cathode. Okay, so you know the definition of reduction and oxidation. Electrons are taking up when electrons are gained by. Whereas if I'm talking about the oxidation, it is releasing an electron. which is taking place at anode. Oxidation is defined as loss of electrons. Okay, so this is the reaction. Then we would combine them, but to make them equal, I'm just going to multiply this with 2, and what we are getting, lead plus 2 bromine. Okay, so this is the reaction. This is the complete process. How does an electrolysis is taking place? Okay, so this was all I wanted to explain you, that you need to remember this particular term, loan, on the basis of which we will start our different cells. But you must have remembered this topic, loan, that is left oxidation, anode negative. That at the left hand side, we sorry, at the left hand side we are placing anode on which negative ions are moving and oxidation is taking place over there. Okay, so now let's begin with our next topic. But before going to that topic, that is the cell, I will just describe you the Faraday's two laws, okay, which are very common. First, we are going to study the Faraday's first law, because on the basis of electrolysis, we have got the idea, we have covered the concept that electrolysis is something in which our electrolytes are decomposing, they are dissociating. Like if I'm talking about lead bromide, they are dissociating into lead and bromine, and there is both oxidation as well as reduction is being taking place. Okay, this was all about electrolysis. So now let's start with next topic, that is Faraday's laws. Let's start with first topic, what is Faraday's first law? Okay, let's start. What is Faraday's first law? Acha bache, now can you ask me what is the importance of electrolysis? See, electrolysis is nothing which we have understood in our syllabus. Like it's not mentioned in syllabus that we need to learn electrolysis. But these were the basic terms on the basis of which our whole electrochemistry is dependent. Okay, so these are the advantages of electrolysis. Like we can say, on the basis of electrolysis, we can prepare our cell. On the basis of electrolysis, we can make our oxidation reduction process differentiate, and we can say that yes, after taking place of electrical energy, these changes have been taking place. Okay, so let's start with Faraday's first law. Till now, we have studied just the qualitative aspects of electrolysis. Means अभी तक हमने electrolysis को सिर्फ theoretical way में पढ़ा था. Now we are going to discuss the electrolysis in the form of mathematical equation. So now we are going to study the quantitative aspects. और उस quantitative aspect को study करने के लिए we are taking Faraday's law. So the first law of Faraday is defined as the amount of chemical reaction and hence the mass, the amount of chemical reaction and hence the mass of, we can say, reactant is directly proportional to the amount of electricity passed to it. Let me define it again very well. The amount of chemical reaction and the mass of any substance deposited or liberated is directly proportional to quantity of electricity, is directly proportional to amount of electricity liberated. So W is the mass of electrolyte which is decomposing, and the Q is defined as the amount of electricity which we have been provided. So whenever we are removing the proportionality constant, we get the value Z, which is known as electrochemical equivalent. Okay, and further the Q is equals to IT, that is current into time. The Q was amount of electricity passed, and it is directly equal to the current multiplied time. So if I'm going to combine the equation, what would we get? W equals to ZIT. This is our main reaction. This is our main concept. Okay. So W is equal to ZIT, where I is current and T is time. So if I want to define this in terms of units, what would I say? That Q is in the form of Coulomb, as it is electricity. I is current, so it is in the form of ampere, and T is time, so it is in the form of second. W is mass, so it will be in the form of gram. So W is equals to ZIT. So if I want to define Z, that is electrochemical equivalent, I would say it would be equal to the mass of electrolyte when there is 1 ampere of current is passed through one second. That means I'm saying if I equals to 1 ampere, time T equals to 1 second, W would be equal to Z. So Z is electrochemical equivalent, which would be equal to the mass only when the current and the time would be equal to 1. Okay. So this was all about Faraday's first law. Tomorrow, tomorrow we will start with Faraday's second law, and then we will go to our next topic, the different type of cells. Okay. So in today's class, we haven't read much, but we have discussed the brief idea of electrochemistry. We have introduced the electrochemistry, like what is electrochemistry, why do we need to study it, okay? In which electrical as well as chemical changes are taking place in redox reaction. Besides this, we have studied about electrolysis, in which we have discovered the two particular important topic, lone and RR, left oxidation anode negative, and right in reduction. Okay, the left oxidation anode negative represents that oxidation stays at anode only, and negative ions are moving to anode. Okay, and we have also seen that how is it important, the lone and RR. We have seen this in the form of an example of lead bromide, but this would be much important in the study of different type of cells, electrochemical cell, electrovoltaic cell. Okay. So, and lastly, we have studied our Faraday's laws, in which we have just completed the first law, which says the mass of reactant, or not reactant, the mass of electrolyte, that would be much better sentence, deposited, or we can say dissociated, is directly proportional to amount of electricity. That means I can say how much amount of electricity I am providing, that much amount of electrolyte is dissociating. Hai simple. I am providing so much energy, and with that energy, that particular electrolyte is getting dissociated. Okay, and Q is replaced by IT, that is equals to current into time. And if I'm removing the proportionality constant, we would get the equation W equals to ZIT. Okay, so this was all about today's topic. Now, if there is any kind of doubt or query, we will see that, and tomorrow we will study the Faraday's second. Okay. So now, if there is any kind of doubt or queries, you may please ask to me.